Hi, my name is Wilfred Montenegro. I am part of the second team for the Big Beam competition for Fanshawe College. Currently we're working on the trial design and finalizing the design for the competition. We're trying to meet all of the criteria of the design, minimizing the cost associated with it, so minimum concrete, minimum steel used in it.
We're going to be doing a T-beam. We're going to be having 4 pre-stressed cables running through it to make it a little bit stronger. We're still doing the initial design, so we're not quite sure of all the specs yet. We're just going to be probably wrapping that up today and then sending it off to PCI so they can actually build the beam in the next few months to test it.
Hi, I'm Solomon Asante. I'm the coordinator of the civil engineering program here at Fanshawe, and I teach structures and quite a few structural related courses. We've been engaging students in this international competition for around 7 years now, and the initial ones involved just one group of let's say 6 students, but in recent times we've been entering 2 groups of students, 6 each, and so this year we have 12 students divided into 2 groups, and they have different cross-sections of beams that they are currently designing. Well, the 2 groups, features some of our very best and able students, and they are pretty excited about the competition, and on the average, maybe once every 2 weeks, they meet together and with us, the instructors, to go over their progress, and they look very motivated and very ready to win.
So on May 9th, 2017, we went down to Windsor, Ontario to cast our beam, and we used the proprietary mix, which is a general use mix that PSI has. And on site we performed slump tests, the air and terrain, and the temperature, and they're all within acceptable. So we do that just to make sure that the concrete we're using is in fact proper and ideal for the beam. And then from the batch of concrete we used, we took 6 cylinders, the size, which we'll perform 3 tests on for compressive strength, and we'll perform 3 tests for tensile strength. So essentially, we'll crush it this way and we'll crush it that way. And so generally, the concrete mix is designed for a minimum of 40 megapascals, but in the past it's generally been stronger. So we had our design to 45 megapascals, just to account for that. Currently, right now, we're just waiting for the 28-day curing period, and once that's up, we'll get to test our concrete big beam.
Thank you to Western University for allowing us to use their lab to test the beam. We ended up having some problems with the hydraulics there, so instead of testing at 28 days, we were forced to test at 34 days, delaying our report, and thank you PCI for allowing us to still submit with that. The way that we broke our beam, so it was a 3-point break with a spreader bar, 3-foot total span, 1.5 foot from center line. The roller and hinge were placed at 18 feet apart as per specs. Our loading rate was increased from 2 kilonewtons per minute to 5 kilonewtons per minute after the cracking to speed up the testing, which our rate affected, and our graph shows the increased loading that it underwent after 91.3 kilonewtons.
So after doing the initial computer design for the beam, we found it was going to have a predicted failure of 163.2 kilonewtons. After testing it at Western, the beam actually failed at 161.8, so we were fairly close to our predicted failure rate. It was about a 0.86% error in the failure.
So the prediction for a crack was 89.8 kilonewtons, and the actual was 91.3 kilonewtons, and the margin of error was 1.64%.
It was great seeing the whole beginning to end process of designing a beam and then actually casting it as well as testing it. Our beam fell pretty close to our predictions, so we're pretty happy with the results. And for anybody thinking about doing the competition in the future, I'd highly recommend it.